Hi, good morning, good afternoon, and good evening. My name is Sebastian. Today we'll be looking at the Cox model, that is, the Cox probability hazard model. It's a statistical tool used in survival analysis. There are different survival analysis tools, and we've looked at Kaplan-Meier estimator in our last section. Today, we are looking at Cox model, and the primary goal of Cox model is to study the relationship between the time it takes for an event to occur and one or more predictor variables known as covariates. So, it achieved this by estimating the hazard function, which represents the likelihood of the event occurring at a given time. Now, the Cox PH model is defined as the equation that we can see on the screen. There are three parts to this equation, and I'm going to break the equation down in three parts. The first part is the hazard function at a time given variant of x, right? So it tries to tell us the likelihood of the event occurring at time adjusted for their covariance, which could be age, could be treatments, or depending on what we're looking at, because the events that occur could be deaths, could be disease reoccurrence, or it could be equipment failure, depending on what the context. So the covariant here could be those factors, all right, that occurs at a given time. The second part of this equation is the baseline hazard function. The baseline hazard function. So this is the hazard function when all covariants are 0, and it tries to capture the underlying risk common to everyone independent of covariance. The third part of this is the exponential path that adjusts the baseline hazard according to the covariance. So the coefficients quantify how each covariance affects the hazard. Let me try to explain this further. Just imagine that you are in a race, right? But it's a special kind of race, and the reason why I say it's a special kind of race because the agenda in a race or for an athlete is the first to get to the finish line. But instead of trying to finish the fastest, we are watching how long it takes for each person to finish the race, or if they don't finish at all. Now let's say we want to figure out why some people finish the race sooner than the other. If I throw it open now, there are several reasons, and we could say that because the age or how old the athletes or the participants are, because if you are competing with a kid, definitely it will take the kid longer time to get to the finish line, unlike an adult. So we could look at how long their lower limbs are, though it's not scientifically proven, because we've seen people with short lower limbs propelling themselves faster and getting to the finish line more than or before the people with a long lower limbs. Now, we could also attribute or look at the part of the type of shoes that they are running with. So the reasons could be there, but what Cox model comes in, or where Cox model comes in into this, all of this, is to help us to figure out what makes the difference. So we want to know how likely each person is to cross the finish line at any moment. To figure that out, we're going to do this in 6 steps. And it's going to be with the equation, with the Cox model equation. And the first we're going to look at will be the baseline hazard model. We're going to look at the baseline hazard model, and we would want to say, okay, let's say track, right? Or track's difficulty. Now, everyone is running on the track, so it's the same for everyone. But for example, if the track is smooth and flat, it then means that this will be small, meaning the chances of finishing the race at any moment is low. But if it's really easy, or if it's an easy track, it then means that this as well could be bigger. We don't know exactly the value of this, all right, but it doesn't matter. The course model is more focused on comparing people, so we don't need to know the exact track difficulty. Now, step 2 will be to look at the covariance. And we're going to identify three unique traits of each runner. So let's pick the first one to be their age. We could want to see it from how fit they are, that's the fitness. And let's say the type of shoes or fancy shoes that they wear. So in this instance, it's going to be a categorical variable where 1 means yes. So if they're wearing a fancy shoe, we'll give a score of 1. If they're not wearing a fancy shoe, we'll give them a score of 0, and that will connote as no. Now let's define the coefficients. That will be the third step. The coefficients here, so we're going to coefficient 1 to be 0.2. Every extra year of age makes the hazard. All right. Then the B, we're giving us minus 0.5. Being fit, reduces the hazard, meaning it takes longer to finish. So 3 will be 1.0. All right. So fancy shoes doubles the hazard. So have this at the back of your mind. The step 4 we're going to look at will be, let's put all of this together. Yeah, let's put all of this together. Okay, so let's look at runner 1 or runner A. The age is 30. Let's give the fitness score as 5, and we could look at the fancy shoe as let's say yes here. So what that yes means is that we are looking at, the score will be 1. So this is x1, x2, and x3. Let's plug them. Let's now look at what the hazard function becomes for runner A in this instance. What it becomes for runner A in this instance. So it's going to be remember, the beta function of the first one is 0.2, and the age, the covariant one, is 30. All right, plus, but because of this minus sign here, we are going to have minus, right, 0.5, and the fitness score we gave this is 5, plus the coefficient of beta 3 is 1, multiplied by, remember we said the fancy shoe here is yes. Okay, so we are going to have so it's going to be, right, this is 6 minus 2.5 plus 1. Right? So this is going to give us exponential 4.5, which exponential 4.5 is about 90. What this means is that the hazard is 90 times the baseline hazard. So runner A is more likely to finish sooner. Well, we could say thanks to their threat. So we're going to compare runner 2 in this instance. Let's look at runner 2 or runner B. Let's give the age of runner B to be 40, and the fitness score, let's give it to be 2, and let's say the fancy shoe, let's say no here. Let's say no. So that connotes 0, right? So this is x1, x2, x3. That's the covariance. Now we're going to find the hazard function for runner 2. just as we did in the previous one for runner A. Runner B is going to be, it doesn't change, the coefficient doesn't change, which is, let's remind ourselves the coefficient again, 0.2, 0. So it becomes 0.2. The age here is 40 minus 0.5, remember? Alright, the fitness score is 2 plus 1.0, the fitness, the fancy shoe is 0. Okay, let's simplify this further. So we are going to have this should be 8, if I'm not mistaken, minus this should be 1 plus 0. Everything here is 0. So we'll have exponential 7. Exponential 7 is what? I think it's about 1097. So what this means is that runner B, or runner B's hazard is 1097 times the baseline hazard. Wow. So even though they are older and less fit, maybe the baseline hazard is really big, so they are still likely to finish. So the sixth step would be to look at the hazard ratio. Okay, so we are going to look at of runner A of runner B. So if we are to plug the values there, this is 4.5. Alright, so breaking down further, we could have, we could say minus 7, which is exponential minus 2.5. So this means that runner A is only 8% as likely as runner B to finish at any given moment. Meaning that runner B zoom fast or runs fast. So what does it all mean altogether? What does it mean exactly? What does it mean? Right? The Cox model is like a magical calculator that looks at each runner's traits and figures out their chances of finishing the race at any time. Now, with this math we've done, we've realized two things. One, comparing runners directly, like we did with the hazard ratio, and we've seen which traits makes the biggest difference, the fitness or the fancy shoe. Then the baseline hazard here is like that track. So if it's there for everyone, but we are most focused on the runner's difference. Let's say it's more like being a detective in the race. Thank you for joining me in today's course.